In our everyday world, time seems to flow at a constant rate everywhere on Earth. Each second is the same length as every other second, and every minute is also equal in length. While we have different times in cities around the world, each clock runs at the same rate. In almost every city around the world, it is the top of the hour at the same time. So we think of time as a constant unending even flow of the fourth dimension. However, 100 years ago Albert Einstein formulated his theory of relativity, in which he said time is not constant everywhere. There are conditions and places in the universe, where the rate of time is quite different than here on Earth. Einstein realized that apparent flow of time can be changed by two factors. 1. The strength of the gravitational field where you are. 2. The relative speed of the observer to an event. Both of these relativistic effects on time have been tested and confirmed to be accurate many times. Einstein realized there was a fundamental relationship between the speed of light and the flow of time. If we had a rocket ship approaching us at 1/2 light speed, 93,000 miles per second, and it flashed a beam of light toward us, we would think that the light beam would then be traveling at 1.5 times the speed of light. When the light left the rocket, it was traveling at 186,000 miles per second, and since the rocket was already traveling at 93,000 miles, we might calculate the speed of the approaching light to be 279,000 miles per second. But observers on Earth measure the approaching light beam traveling at 186,000 miles per second. So what is happening? Einstein concluded that time itself was changing. The astronaut on the approaching spaceship and the stationary observer on Earth were seeing the flow of time differently. To help us visualize this relationship between light and time, we will construct two imaginary clocks, which use a single light beam called a photon, to act like a pendulum of a clock. We will place two mirrors 1 foot apart and parallel to each other. We will start the light beam bouncing back and forth between the mirrors. Each time the photon travels from one mirror to the other, we will call it a light tick. This will make a very accurate clock, as the speed of light always appears the same. In real time, the light photon would bounce back and forth over 982 million times per second, making the photon appear as a blur, so we will slow down time so we can see the photon move. We will also make the light photon much bigger, emitting its own light, so we can watch its movement. Now let us start the green clock moving at 1/2 the speed of light. We now notice that the clocks soon get out of sync. It appears that the moving clock is running slightly slower than our stationary clock. Now let us increase the speed of the green clock to 86.6% the speed of light. Now we see the green clock running at half the speed of the blue clock. In the time the green clock makes just one light tick, the blue clock makes 2 light ticks. We will now accelerate the green clock to 99% the speed of light. We now see the photon taking over 7 times as long to travel from one mirror to the other than our stationary clock. Now if we push the green clock to the speed of light, we see that the photon is resting on the surface of the mirror of the moving clock. Both the photon and the clock are traveling in the same direction at the speed of light. The photon cannot reach the other mirror, because it would have to travel faster than the speed of light to reach it. But light always appears to travel at a constant speed, and cannot travel faster or slower. It appears that time has stopped for the moving clock. So why are these clocks appearing to slow down? In one light tick, the photon can move from the starting position to an equal distance in any direction, thus forming a circular arc. For the blue stationary clock, the photon moves vertically to the top mirror. For the green clock, it will be moving to the right. Its photon appears to be traveling at an upward angle to the stationary observer. The faster the clock moves, the greater the angle becomes from the vertical. The greater the angle, the further the distance the photon must travel to reach the top mirror. As both photons are traveling at the same speed, it takes longer for the green clock's photon to reach the other mirror. Zooming in on the diagram to the last percentile, we find time gets stretched out to extremely long times. To the stationary observer, he will see time in this last percentile stretched anywhere between 7 times longer, to infinity. So for the light photon there is no concept of time. They start their journey through space, and reach their destination in the same instant. It doesn't matter if they are just traveling across the room or across the universe, the travel time is always the same, 0. So if you were a photon, would you even know that you exist? Your life and death happen in the same instant. Yet for us stationary observers we see time elapsing, as the photon travels from one place to another. For us humans there is a dimension of time, but for the photon there is no dimension of time. Yet, to an astronaut, traveling with the green clock, everything seems normal aboard his spaceship. He sees the photon bouncing back and forth between the two mirrors, in a normal fashion keeping perfect time. However, when the astronaut looks out his window, the universe seems somewhat distorted. Directly ahead stars look much closer and the stars look very blue. Looking out the side window stars seem to be flattened in the direction he is traveling. Looking behind the spaceship the stars appear far away and very red in color. As Einstein points out, time seems relative to the observer. Two observers can see the same event, but disagree on the timing of the event. For instance, if an astronaut was traveling to a star 25 light-years away, and a spacecraft was traveling at 99.9999% the speed of light, Earth-based observers would see him taking a little over 25 years to reach the star. However, the clocks on a ship would show that the trip only took several weeks, because his clocks were running much slower than Earth clocks. This duality of time has an interesting aspect, when we consider the age of the universe. In the last decade, cosmologists have been able to determine that the universe is about 13.7 billion years old. NASA scientists are very confident of this determination, giving the margin of error as only plus or minus 0.2 billion years. Scientists also know that at the beginning, the universe was mostly energy, very hot, and very bright. Nearly all this energy was in the form of photons in the first instant of time. Because of this it is very likely the universe expanded at the speed of light. Some scientists, who follow the inflation theory, say the universe expanded faster than the speed of light for a period of time. In either case, we have the universe expanding at relativistic light speeds. Some of the first photons may have never collided with anything, and thus are still racing away from the starting point, all in an instant of time, to them. Based on our Earth clocks, and others based on the effects of relativity on the light speed expansion of the universe. It could be that both NASA and the Bible are telling the same story, but from a different space-time frame viewpoint. While there are other explanations for the age of the universe controversy, I think this is the most scientifically compelling answer. The book, Discovering God in Science, explores a number of interesting science discoveries, which point to the need for an intelligent creator, to have made the universe, and us humans. Available at the website www.discoveringgodin.science.com.